Here we go. We have a question, find missing and repeated values. So you have given a 0 index to the integer matrix of size n cross n with values in the range of 1 to n square. Each value appear exactly once except a which appear twice and b which is missing. Our task is to find the repeating and missing numbers. We need to return an array answer where the zeroth value is a, which is which is repeating, and b which is uh, missing. So in this example we have n as 2, so the value should be 1 to 4. 2 is repeating, 4 is missing. In this test case we have n as 3, so the value should be in the range of 1 to 9. 9 is repeating and 5 is missing. So let's build the approach. Question is pretty straightforward. So let's suppose we have given this array, and in this the repeating is 2 and missing is 4. So let's build the approach. We're not gonna use any space. I know there's an approach in which we can utilize space. We can use hash map or dictionary and find the frequency, but in today's approach we are not gonna use any space. So our first approach will be to use XOR. So first we do the XOR of all the values, then do the XOR with all the values between 1 to n square. Our n is 2 in this case, so 1 to n square. So this will cancel out, this will cancel out, this will cancel out. We got this. Our XOR, what is XOR? This is 4, this is 2, so XOR is 6. Then we find the LSB, least significant bit, which is this position. So position number is the 2 raised to power 0, 2 raised to power 1, 2 raised to power b. So our bit is 1, which is this, which is this. So we need to find the least significant bit. How we will find the missing and repeating number? The least significant bit means this bit is set. It means one value is 0 and another value is 1. So that's why we are getting XOR, and XOR is set. Then we're gonna divide the values into buckets, in which our first bucket, in which all the values in our first bucket, that bit is set, and in the second bucket that bit is not set. So the value we have is 1, 2, 2 and 3, and we also gonna need 1, 2, 3 and 4. So let's find out in which all the in which we have one bit as set. So 1 first, let's write 1. What is 1? This is 1 only. So this is 0th bit set, but 1th bit is not set. So this belongs to bucket number B. Then we have 2. 2 is right. 2 can be written as this. So 2 belongs here in bucket A because 1th bit is set. So then again we have 2. So 2 is here. Then we have 3. 3 is this. 3 belongs here. We have 1. 1 belongs here. 2 belongs here. 3 belongs here. Then we have 4. 4 is this. 4 belongs here. So this will cancel out, this will cancel out. We are doing XOR here. This will cancel out. Then A is 2, B is 4. So we identified A and B, but we are not sure whether A is repeating or B is repeating. So we know our array. Then in this we gonna find if there's an A in our array, we just gonna return A and B. If B is in our array, then we return A and B. It means our A is repeating and our B is missing. So let's quickly code this. So this is our first approach, and we first need to find n. Our n is this. Then just iterate. Find the XOR. Then we need to find LSB. So let's say we need to find our bit number. This is 0 initially. Then our bits iterate till 32. If XOR and this number, we are getting some value, it means that bit is set. That bit is set in XOR. So then just break bit is B. We know our LSB. Then we're gonna need to divide into two brackets, which is A and B. Just iterate first in this array. I think I missed one iteration, which is to iterate 1 to n square and to XOR with value I. Then if that bit is set in J, 1 XOR bit, right? That bit is set, it means this belongs in A, otherwise the value belongs in B. Same iteration for this. Same iteration for I. Then we know our A and B, but we don't know whether A is repeating or B is repeating. So we need to again iterate in grid. If J is equal to A, just return A and B. If B is repeating, just return B and A. Else no, nothing will be there. So let's run this. Then we have an error here because this is I. We have I here. Yes, let's submit this. Yes, it is submitted. Now for once let's find what it is doing. So first we are doing the XOR. So let's go to the whiteboard. So first we are finding XOR between these values. So we got 1 XOR 3, right? Then we are doing XOR between 1 to n square. So again we are doing 1, 2, 3 and 4. We are doing XOR between this and this. This will cancel out. We got 2 and 4. That's why we got 2 and 4, which is 6. So after getting this 6, then the next thing is to find LSB. So what is this thing? I know this is very complex. So what is this? So this means we have a number as XOR, then we are doing AND. So the number is 6. So let's find out. The number is 6. This is XOR. Then we are iterating. So 6, how 6 can be represented? 6 can be represented as this, and again zeros. This is 0th position, 1 position, 2, 3, 4, 5, 6, 7. Then and this will iterate till 32 or 31, right? Then this thing, 1 left shift b times, 1 left shift 0 times. Then we are doing AND operation. We go to 0, all values is 0. Then in our next iteration b will become 1. So 1 left shift 1 time, so 1 is here and all values 0. Then we are getting some values which is greater than 0, right? Yes, if this is greater than 0, it means this is our LSB. So our bit will become B, our bit will become 1, we are shifting one b number of times in left. Okay, after finding our bit is 1. We know our bit is 1, so we find our bit. The next thing is to um, iterate in grid. So this again, same thing happens here. We are doing on that bit. So suppose we are given 1, so 1 is represented as this only, 0 0 0 then 1. So our bit is 1, so we are left shifting 1 bit number of times. Again I'm repeating, we are shifting 1, we are left shift 1 by bit number of times. So it will look like this. Is it equal to greater than 0? No, it means 1, this bit position is not set. Then let's check for 2. 2 is written as this and bit is 1. It means we are left shifting 1 by bit number of times. So it will look like this. So it is greater than 0. It means our that bit is set. So we are adding that value in A. So we have find A and B. After finding A and B, we have only did this operation on array A. But we have not done on 1 2 and square. We need to do this also. So we have done that here also. Then in our next iteration, we know our A is 2, B is 4, but we don't know whether A is repeating or B is repeating. So we need to again iterate. If we find A here, our A is 2. If I find A here, it means A is repeating, else B is repeating. So that's about approach 1. Now let's build the approach 2. Approach 2 is going to be very simple. This approach 2 is mathematical. First, let's suppose our A, x is repeating and y is missing, right? So what's the summation of this? So summation is 1 plus 2 plus 2 plus 3. Then we subtract with summation of n terms, which is 1 plus 2 plus 3 plus 4, with summation of n terms. So we got cancel, we got minus 2. So s minus sn is equal to minus 2. What is this? This is 2 minus 4, which is s minus sn, right? This is 2, this is 4. So 2 minus 4 is s minus sn, right? So what is 2? Isn't 2 repeating? Yes. Isn't y missing? Yes. So x minus y is equal to s minus sn. We can write it like this. Or its value is equal to minus 2, right? So we know x minus y is equal to minus 2. Okay, we know one equation, but we cannot find both values using one equation only. We need to do something else so that we know another equation. So let's find s square. So 1 square plus 2 square plus 2 square plus 3 square. Then we subtract sn ka square. So we got 1 square plus 2 square plus 3 square plus 4 square. This will cancel out, this will cancel out, this will cancel out. 4 minus 16, which is minus 12. What is this? This is repeating. So we can write x square. What is this? This is missing. So we can write y square. So we know x square minus y square is equal to minus 12, right? So what is this? This can be written as x plus y, x minus y, which is minus 12, right? Then x plus y is equal to minus 12 by x minus y. What is x minus y? Which is minus 2. Minus 12 minus 2 is equal to 6. So we know two equations, x minus y, which is minus 2, and x plus y, which is equal to 6. So we can calculate like this, which is 4, our x is 2. So we have find our x, but x plus y is equal to 6. Y is equal to 6 minus x, y is equal to 6 minus 2, y is equal to 4. So we have found both values, right? So this is based on mathematics, and we can solve this question. So we have found two values. So what we need to do? First we need to find s minus s s minus sn, which is x minus y. Then is x square minus x square n, which is x square minus y square, right? So first let's find this value. But before jumping into this, what is Sn or what is S square n? Sn, summation of n terms. Summation of n terms. We can write it like this, right? Summation of n terms. Summation of n square terms. We can write it like this. This is school math. So we just need to find S and S square. So let's code this. So let's first find the size, and then n is size multiply size. Let's take long to be on a safer side. Then we need to find s and s square. Then s square will be equal to j multiply j, but j is integer, so to be in a safer side we need to multiply with long. Then what we need, so we have found two values, which is s and s square, but we need sn and s square n. Sn and s square n can be calculated using math only. So let's say sn is n multiply n plus 1 by 2, and s square n, which is equal to n multiply n plus 1 multiply 2n plus 1 divide 6 to n. Okay, so we have found this and this value. Okay, so we have found x minus y. X minus y we have not find. We know our four values, so let's calculate x minus y first and x square minus y square. So x minus y will be s minus sn. Okay, then let's find x square minus y square, which is x square minus y square, which is x square minus s n square. S square minus x square n. Okay, so we have found our two values, which is x minus y and x square minus y square. What is x minus y? X minus y is value is this. So let's write here x minus y value is minus 2, and x square minus y square value is minus 12. X plus y can be calculated as x square minus y square by x minus y. So let's first find this x plus y. So this is x plus y long x plus y can be written as x square minus y square divide x minus y. Okay, so we find our two equations. And our x plus y is 6. So we know two equations. So this and this. So let's sum it up and find the x. What is x? X is x minus y, this value plus this value divided by 2, right? Yes, which is 2x minus y plus y by 2, which is x only. right? So we can write it like this: x minus y, x plus y by 2, x minus y plus x plus y, x minus y plus x minus y plus x plus y by 2. And what is y? Y, we know our x. Our x is 2. Our x is 2. So we know our x plus y. So to find y, we can write it like this: x plus y minus x. Yes. So y is x plus y minus x minus x. Then just return the values. This will not work. We have to convert into integer. Yes, let's submit this. And yes, working fine. In both of the so in this, time complexity is n square, time complexity is n square, and space is constant. In our previous approach, which is this, which is XOR, again the time complexity is n square and space is constant. And if you like my content, give it a thumbs up and subscribe to this channel. Thank you all for watching this video.